A pair of linear equations in two variables are of the form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, b1, c1, a2, b2 and c2 are all real numbers and a1 square plus b1 square not equal to 0, a2 square plus b2 square not equal to 0. The three cases of the solution of a pair of equations in two variables can be found out graphically or algebraically, that is by using the algebraic methods of substitution, elimination and cross multiplication. So, in order to reach to this extent, be it in any format, first of all, we need to reduce the equations in their standard form. Let's see how we can do that with a few examples. Solve the pair of equations 1 by 3x plus 1 by 2y equal to 4 and 1 by 5x plus 1 by 3y equal to 7. To solve these equations at first, we need to reduce it to the standard form, that is ax plus by plus c equal to 0. Given pair of equations can be written as 1 by 3 into 1 by x plus 1 by 2 into 1 by y equal to 4 and 1 by 5 into 1 by x plus 1 by 3 into 1 by y equal to 7. Let's consider them as equations 1 and 2 respectively. But still, it's not in the standard form. However, if we substitute 1 by x equals p and 1 by y equals q in equations 1 and 2, we get 1 by 3 p plus 1 by 2 q equals 4 and 1 by 5 p plus 1 by 3 q equals 7. Taking LCM for the fractions of RHS of each equation, we get 2p plus 3q whole divided by 6 equals 4 and 3p plus 5q whole divided by 15 equals 7, which is 2p plus 3q minus 24 equal to 0 and 3p plus 5q minus 105 equal to 0. Let's consider these as equations 3 and 4 respectively. Now these equations are the standard form of a pair of linear equations in two variables p and q. Solving this, we get p equals 195 and q equals 138. And since 1 by x equals p, x equals 1 by p, which is equal to 1 by 195. Similarly, since 1 by y equals q, y equals 1 by q, which is equal to 1 by 138. Hence, we have the solutions x equals 1 by 195 and y equals 1 by 138. Now, let's see another problem. Rahul wants to build a rectangular swimming pool in his house. The area of the pool will be decreased by 2 square meters if its length is decreased by 2 meters and breadth is increased by 1 meter. Its area will be increased by 10 square meters if the length is increased by 2 meters and the breadth is increased by 1 meter. Find the dimensions of the pool. Let the length of the pool be x meters and the breadth of the pool be y meters. Then the area of the pool will be xy square meters. According to the question, the area of the pool will be decreased by 2 square meters if its length is decreased by 2 meters and the breadth is increased by 1 meter. Decreasing the length by 2 meters means it's x minus 2 and increasing the breadth by 1 meter means y plus 1. To get the area, we multiply the new length and breadth, and 2 meters less than the old area means xy minus 2. Let's consider this as equation 1. The next information is that the area will be increased by 10 square meters if the length is increased by 2 meters and the breadth is increased by 1 meter. The corresponding equation formed will be x plus 2 into y plus 1 equals xy plus 10. Let's consider this as equation 2. Multiplying throughout in the equations 1 and 2 and cancelling the like terms, we get x minus 2y equal to 0 and x plus 2y equal to 8. Let's consider these as equations 3 and 4 respectively. Now these two equations are a pair of linear equations in two variables x and y in their standard form. So we can solve them to get x equals 4 and y equals 2. So the dimensions of the pool are the length is 4 meters and the breadth is 2 meters. The next problem is a boat goes 20 kilometers upstream and 35 kilometers downstream in 9 hours. In 12 hours, it can go 33 kilometers upstream and 48 kilometers downstream. Determine the speed of the stream and that of the boat in still water. Please note that while a boat goes upstream, that is opposite to the direction of the stream, the speed of the boat will be reduced by the speed of the stream. And while in downstream, that is in the same direction of the stream, the speed of the boat adds up with the speed of the stream. Let the speed of the boat in still water be x kilometer per hour and the speed of the stream be y kilometer per hour. Then the speed of the boat downstream equals x plus y kilometer per hour and the speed of the boat upstream equals x minus y kilometer per hour. Also, time equals distance by speed and total time equals time taken to go upstream plus time taken to go downstream. Then 7 equals 20 divided by x minus y plus 45 divided by x plus y and 10 equals 30 divided by x minus y plus 60 divided by x plus y. Let's consider them as equations 1 and 2. Let 1 by x minus y equals p and 1 by x plus y equals q. Consider this as equation 3. Substitute this in equations 1 and 2. We get 20p plus 45q equals 7 and 30p plus 60q equals 10. Let's consider these as equations 4 and 5. Now, these have become as the standard form of a pair of linear equations in two variables p and q. Solving them, we get p equals 1 by 5 and q equals 1 by 50. Substituting these values in equations 3, we get 1 by x minus y equals 1 by 5 and 1 by x plus y equals 1 by 15, which means that x minus y equals 5 and x plus y equals 15. Let's consider these as equations 6. These are a pair of linear equations in two variables x and y. Solving these, we get x equals 10 and y equals 5. Therefore, the speed of the boat in still water is 10 km per hour and the speed of the stream is 5 km per hour. So, we can conclude that there are several situations which can be mathematically represented by two equations that are not linear to start with, but if we alter them so that they can be reduced to a pair of linear equations.